I'm not happy that these videos are going a little bit over 20 minutes. I'm gonna try to cut out the fluff a little bit and show you how fast you should be able to do these if you study well over the weekend. This third study sheet, looks like it's, oh, I love this one. We have the totem pole, and we're going to learn how to make the different heads of the totem pole, starting with the top, acid chloride. Best way to make an acid chloride. Now, your example doesn't have to match mine, but your functional groups need to, because to make an acid chloride, carboxylic acid, SOCl2, sometimes I put pyridine and I abbreviate PYR. I want to make this I want to make this shorter and more time efficient, but also I want to put the essential information. To make an acid chloride, start out with a carboxylic acid. And the acid chloride looks like this. You want to know how to make an acid chloride because it is the most reactive carboxylic acid derivative. And from here, you're going to see we can make a lot of different molecules. Now, I am good enough that I don't have to use my notes, so I have no idea what box this is. But if you're having trouble with this first one, how to make an acid chloride, and you're shuffling through your handouts, why didn't you put what box, right? This is reaction, blah, blah, blah. So that way, if you get stuck again, you could find it a lot faster. And you'll start to, develop kind of a sense of where things are. Where are your car keys in the morning? Where's the lunch? Well, it's in the refrigerator. But where's your backpack? Where's your laptop? Okay? And so you can find it quickly and, get on with your task. And the second task is the best way to make an anhydride. That's from the acid chloride. So I'm going to use the same acid chloride that I just made, and I'm going to use it to make an anhydride. The anhydride I want to make, let's make it with we call this a tert butyl group. Okay, is that all we need? Yeah. And so the trick is know that you start with an acid chloride, which makes sense. It's the most reactive. So let's use its reactivity to our advantage and pair it up with carboxylate that gives us the anhydride that we want. So I'm not showing you what anhydride I want. I'm not showing you what acid chloride I want. I want you to have some creativity and make up an acid chloride that you want to synthesize, or make up an anhydride. Okay? And so the anhydride that I made is this. Okay? 3 ways to make an ester. Oh boy. Well, the most popular way actually is the last way we learned how, and that is Fischer, the one you're doing in lab. Fischer esterification. And so we're not starting with a derivative with Fischer esterification. We are starting with, which one do I want to make? We're starting with the carboxylic acid, or a carboxylic acid. Now, if I pair it up with an alcohol, and the alcohol I'm going to use is, I like rings, this alcohol. Just remember that Fischer esterification is under acidic conditions. Okay? This is what we learned in class on Friday. And so here we have the ester. We're making an ester. So just draw an ester and match the groups that you see from the carboxylic acid and the alcohol. That's one way. Oh, the second way we're going to list here is, well, I just got done saying that this acid chloride is very reactive. Okay, let's go from acid chloride. Some people call it acyl chloride, but I like acid chloride. Okay, do you want to try to make the same ester? Let's do that, so we can compare and not be distracted by the differences in the R group, in the carbons. So the big difference is we start with an acid chloride, and we pair it up with the appropriate alcohol. This is not acid catalyzed because you know that acid chlorides are very reactive. And so it just mix those two, and we get the same product. If you don't see it, yes, you could do the mechanism, but I'm hoping when you come to my drop-in hours regularly, you'll see that it's I don't know. I feel like it's easier actually to learn how to draw the product before the mechanism. And then I use a mechanism to kind of prove, oh yeah, it's logically, this is a logical pathway to get to the product that I know how to draw. Next. Well, this anhydride is also pretty reactive. And so I could add any type of nucleophile, kick out this leaving group, and I could get the ester, or later on we'll see the amide. So I just need to, what do I attack? What do I use to attack? I use an alcohol. And so this is a little bit trickier because now you have to make sure that your anhydride is symmetrical. So no matter which carbon you attack, you'll get the same product. So whether you attack the carbon on the left or the right, you're still adding, right, to the ester, this part. And again, Friday's class, we were always adding, not always, but we were adding alcohol to a reactive derivative. And so your ester would look like this. And I understand that you had a kick-out group, that you don't, a little sloppy, that you don't have to draw. But the kick-out group was this. Right? It was this piece here. And yeah, I could put a dot. I used this as the carbon that was attacked. Same thing here. Same thing here. Okay. This is from the anhydride. From anhydride. Okay, last, we have not learned how to make amides yet, because to make an amide, right, you have to have an amine attacker. We've only looked at water and alcohol so far, and hydroxide in the case of saponification. So we'll get to number 4 on Monday. The last one is 2 ways to hydrolyze. And, okay, great. Why don't we use, look at this fancy move here. Why don't we take this ester and hydrolyze it. Okay, we're going to hydrolyze it to the right and to the left. To the left is what we learned first. I'm going to use purple. Acid catalyzed hydrolysis. An ester is one of the less reactive derivatives, and so we're going to use some acid catalysis. Sometimes I use heat, and sometimes I don't. Sometimes, right, I draw the acid like this, right, H3O+. Okay, so your hydrolysis products are here. This is the one where everything is neutral. Okay, don't get so panicked about these charges, right? That you don't get so panicked about that charge and this charge that you start putting charge all over the place. Okay, it has to make sense. it has to be under acidic or basic conditions, but also you have to have the right partner. We're here under acidic conditions, so it's going to protonate anything that's basic, but we don't have anything that's basic, right? We have things that are acidic, the carboxylic acid and the alcohol. Those are both more acidic than they are basic. And then going to the right is saponification. Under base, right? Saponification. And the base, KOH or NaOH. And yeah, you gotta put water. Because water is the one that's actually... I was gonna say it's an attacker, but it's actually not. Water is the one that helps, protonate or deprotonate to get to the final product. And so we have this plus the alcohol. Okay. Did anyone catch the mistake? You have an acid under basic conditions. Get rid of this, right? This is the O-, the carboxylate. With saponification, again, if you verbalize it, you won't forget it. With saponification, watch out. Watch out, because you're forming the carboxylate. And I'm going to write that down. Carboxylate. And that's the difference in products between acid catalyzed and base mediated. Neutral carboxylic acid, carboxylate. Why is this study sheet helpful? This particular study sheet is, hey, we're in the chapter of carboxylic acid derivatives. We better know how to make those derivatives, whether it be a acid chloride, anhydride, ester, and then we're going to do amides on Monday. Okay, good luck. I do expect, if you're having trouble, at the very least go through this video and take notes. All right, if you're not having trouble, okay, make your own study sheet. You don't necessarily need to use this one. You have it under control. But this is just to help those who, again, man, what does he mean by make, a one-page study sheet or to make a roadmap? And is it going to be useful? It's going to be useful, especially if you make your own. But here I'm giving you an idea of how to go about that. Under 20 minutes.